Alright guys, this last video is just kind of random miscellaneous stuff that we did this chapter that didn't fit into any of the other three videos. So calculating slope we actually went over in one of the others, but just in case, y2 minus y1 over x2 minus x1. So that would be 5 minus 3 over 1 minus the negative 2 becomes plus 2. And then if you do that, that's 2/3. So that's the answer there. And I need to grab a sip of water. Okay, finding slope with units, we're just going to count. We're going down 1, right 2. Down 1, right 2, so it's negative 1/2. And then the slope for units is change in y divided by change in x. So gallons per hour. Remember, you need both. Gallons per hour for slope because it's a rate of change. Types of numbers, we didn't do too much with this. So instead of filling this out, let's just look at this one here. So a basketball stadium can hold up to this many people. Here is the revenue function. X is the number of tickets. What is the domain? So remember, domain is all the X values, and range is all the Y values. Okay, so domain is the number of tickets. But the question is, what kind of numbers can be tickets? So then you start thinking, okay, so tickets could be, so the whole numbers are no negatives and no decimals. The integers can be negative. They can be negative, but still no decimals. And then I think we also did rational numbers. The rational numbers can be decimals, repeating decimals. They could be repeating decimals or terminating decimals as well. So the question is, what makes sense for tickets? Can tickets be decimals? No. Can tickets be negative? No. So they have to be whole numbers. All right, so you would say whole numbers, but is there any restriction? They can only seat this many people, so less than or equal to 23,567. That would be the domain. Okay, then we did functions, which some of you thought was pretty hard. Functions are just, let's see what we did with that. So if we give you guys something in function notation, remember f of x really just means y. Okay, when it says x equals 3, they literally just want you to plug in 3 for x. Okay, so y is going to be 3 times 3 minus 5. And that ends up being 9 minus 5 is 4. Now this one's saying when the function value is 7, so like when y is 7, so that means the 7 goes here. And they want you guys to solve for x. So if you add the 5 over, you get 12 equals 3x, and then divide by 3, x is going to be 4. Okay, so make sure you do the right thing there. And then we did function versus not a function. Remember, every input can only have one output. So look at this guy. The 1's going to the 5 and the 3, so it's not a function. Can only go to one output. If it's a graph, it has to pass the vertical line test, where any vertical line can only hit the graph once, but it looks like we're hitting twice. So that's no, not a function. And then this one, every input can only have one output. So as long as no x's are repeating, we're good. So I would say that this one is yes. Yes, it is a function. And then we have these ones off a graph. So let's see if we could solve these. So f of negative 8 means when x is negative 8, what's the y value? So go to x equals negative 8, and then find where it hits the function here. What's the y value there? And it looks like it's at 4. Now this one means when x is 4, what's the y value? So go to x equals 4. It looks like it hits the graph here, and that's over at y equals 1. Now these are backwards. This is saying the y value is negative 2. So when y is negative 2, where does it hit the graph? It hits it here at x equals 3. And then lastly, when y equals 6. So go to where y equals 6. That hits the graph here, and that's when x equals negative 4. Okay, so just make sure you're looking at the right part of the graph. All right, that was our miscellaneous. Thanks for watching.